Greetings to you all. So, variation of parameters, it's a little bit, perhaps, I don't know whether you like it or not. It's actually kind of cute how it works, but you need to know a little bit what you're doing here. You have to keep track of what you're doing. Now, normally, the first thing you need is a fundamental system of solutions for a complementary homogeneous. And they normally give that to you, but this time they don't. Why? Well, because we can find it out. But the complementary homogeneous equation is actually rather simple. It's constant coefficients, and we know how to do that. Okay, so this is constant coefficients, and that's why they don't need to give it to us. We know how to do that. Okay. Now, it is not of the form of in the chapter 5.4 and section 5.4 where we had the exponential times a polynomial. This is a trigonometric, so it gets a little bit messier for that reason. Okay, so step one. Well, we know that because it's a constant coefficient, we have to look at the characteristic equation, which is t squared plus 9 equals 0. Now, if you take the 9 to the other side, minus 9, you see you're going to have a complex solutions, right? So it's going to be plus or minus square root of 9, plus or minus the square root of negative 9, which of course plus or minus I times the square root of 9, which is plus or minus 3i. Okay, so what does that mean? Remember, we write our solutions with a lambda and an omega. So here lambda would be 0 and omega would be 3, right? Plus or minus. And then we know that the general solution is e to the power. So the general solution would look like e lambda x, and then we have a times cosine omega x plus b sine omega x. Or you can put the first two sine and then the cosine. Now, okay, lambda is 0, so there's actually no e. So we get a cosine 3x plus b not cosine, not twice the same thing, of course, b sine 3x. We always take the positive. You can take the negative, but why would you? It gives the same thing. Okay. So now the variation of parameters. What does that do? So we introduce parameters u and v. Let's call them u and v. It's a bit simpler. And what we're looking for is a solution where we use these two guys. We replace basically the constant by this u and v. So we get u cosine 3x plus v sine 3x. That's the solution we propose. But we are not going to plug this in. I mean, you can, but it is a lot of work. So let me first box this, because this is where I'm going to have to go back to. What we solve is, solve the following system. That is very important, right? So what you do is, first of all, you take the same cosine sine x, but now with for the u prime. And say that has to be equal to 0. And then you keep the u primes, but you take the derivative of these two guys. The derivative of cosine is minus sine, so that's minus 3 sine 3x. The 3 comes from the inside function, right? And this would be plus 3v prime cosine 3x. And that you put equal to the forcing function, tangent 3x. So this is equal to tangent 3x. Okay. Right. And what then? Next thing you have to do is solve for one and plug it into the other. And okay, obviously we're going to use this one here. Let's do u prime cosine 3x is equal to minus v prime sine 3x. So that means that u prime is equal to minus v prime tangent 3x. It's a bit easier if I write it with a tangent instead of the cotangent. I prefer to work with tangent and secants rather than with cosecants and cotangent. So that's why I solve for u prime. And then so this is solving. I solve this equation and then we substitute here. So we substitute, right? So we get minus 3 times u prime, which is minus is 3v prime. We have sine 3x times tangent 3x, which is actually, well, okay, let me write for the moment tangent 3x, plus 3v prime cosine 3x, right, that is just that one, equals tangent 3x. Oh yeah, that's not so nice, right? First of all, we do not have like terms here, do we? Well, tangent is sine over cosine, right? So let's see what we have here. We have 3v prime, and then this is sine squared 3x over cosine x, 3x. I'm writing tangent now back in sine and cosine. Okay. Plus cosine 3x. So perhaps I should put this on a common denominator. So put this a square here and then the cosine 3x here, right? That's I'll put a common denominator. I start liking it better because what is this now? So I'm working on the left hand side. That is 3v prime. That is cosine 3x, and on the top I get sine squared 3x plus cosine squared 3x. Now, sine squared plus cosine squared, if the arguments are the same, that's just 1. So this whole thing is just 1. Oh, that is good. And that is equal to sine 3x cosine 3x, right? Oh, even nicer, the cosines cancel. So we get 3v prime is equal to sine 3x. Okay, I can deal with that. So this means that v prime is 1/3 sine 3x. So that v is equal to, and so what we do here with the coefficients, we keep track of all the coefficients, right? No, we don't. We're looking for a particular solution. I'm sorry. Because we have the homogeneous solution, right? We have the homogeneous solution here, so we're going to just later add that. Okay, so we antiderive this is the antiderivative of sine is minus cosine, right? So minus 1/3 cosine 3x, and I have to think about what happens with this 3 in the side, so I have to divide by another 3 here. So I find that v is minus cosine 3x over 9. But I also I need u prime. Now I solved u prime here, and I know what v prime is, so let's plug that in here. So combining these two, don't start taking the derivative of this again to find v prime, you have it, right? Don't go back, don't do double work here. So I find that u prime is equal to minus v prime, which is minus 1/3 sine 3x, times tangent 3x, which is sine 3x over cosine 3x. Okay, now that looks a little bit different. Well, it's again an antiderivative problem, so u is 1/3, and now I have to antiderive. What is this? Sine squared 3x over cosine 3x dx. Right. Yeah, this is a trigonometric integral. We haven't seen, you were hoping we would not run into these things, but once in a while we run into these things. And the normal ones are if we have sines and cosines, but all on the same level. This is not the case. We have a sine on top and a cosine in the bottom. You could try to transform it into tangent and secant, but I don't think it will work either here. So what we need to do here, well, this is where we use our identities, right? We know that sine squared is 1 minus cosine squared. So no, that's not going to work. Yes, no, so I will have 1 minus cosine squared 3x, and I have to divide this by cosine 3x dx. Okay. Still, you could say, substitution cosine 3x. No, because what we're missing is a sine 3x then. The derivative of cosine 3x is sine 3x. We don't have that. Sure, we can say, okay, here, take this one, and then do the substitution cosine 3x, and you have a sine 3x. What are we going to do with the other one? Because it's sine squared, right? So here we do, this is a little trick here, so that's, okay. That's why I wanted to do it separately for you. So this is 1/3. What I'm going to do is actually really doing the divide here. So the first time was 1 over cosine 3x minus cosine 3x, right? This one of the squares, the square would cancel and we get this. Okay, you're following so far? Now this cosine, 1 over cosine 3x is secant 3x. Let me write it that way right away. So this is secant 3x. I kind of remember that there was a special formula for this thing. That was 1/3, and then the antiderivative of secant was ln of secant plus tangent. That was a weird formula, but that's what it was. Now we have to be a little bit careful because there's a 3x here. So if I take the derivative of this whole thing, I will get secant 3x times 3 because of the inside function. So I'm gonna have to divide by 3 here. That is the antiderivative of this guy, right? Minus 1/3, expanding and putting the 1/3 in both here, otherwise I'll get confused. And the derivative of cosine is sine 3x, and again we want to have an extra 3 here, okay? That's it. So what we get is 1/9, the whole thing is 1/9, and then we have ln secant 3x plus tangent 3x minus sine 3x. And then this is u. So where are we? A little bit of space here. Let me move this guy. This is the second one already. I wrote it down. Let me move this down a little bit. Go down. Okay, that's enough. So we know that y. Oops. This is our particular solution. No, wait. Let's see. No. What is our particular solution? That is u. Remember, this is our boxed or orange here. U times cosine 3x plus v sine 3x. Let me write it again. U was this fellow, so that is 1 over 9 ln secant 3x plus tangent 3x minus sine 3x, and I'm going to multiply this with cosine 3x plus v, well v was minus cosine 3x over 9 minus cosine 3x over 9, and then times sine, where is my, times sine 3x, okay. Okay, yeah, and there is a couple of things you can simplify here. In fact, this term here is the same as this term, but they don't cancel, they both have a negative sign. But so you could combine them. They are like terms. Let me see here. The form, I want to see what the form was that they give in the back of the book. Let me scroll down. This was 5.7, right? 5.71. Well, they say they cancel, so did I make a minus sign mistake then? There's a minus 1/3 here. Could be that I made this mistake. According to them, these two can cancel out. Let's see here. U cosine plus v sine 3x. And v was, I had a negative sign here. Is that correct? The antiderivative of sine is, of cosine is, yeah, so it's a negative sign. So that v is a negative sign. Where else was it? Then this negative sign. Well, because that's comes from 1 minus cosine square. U prime. Did I have u prime? Where did I get u prime from? U prime is minus v prime tangent, and I see here. So I think that here it is, right? V prime is here. Sorry, v prime is 1/3, and u prime is then minus this guy tangent 3x, and I didn't have the minus here. So sorry. So this has to be a minus. So this is a minus. This is a minus, this is a minus. The whole thing is with a minus. Everything is the same except that there's a minus here. Right, so this is a minus. And now we do have, if you look at it, this is a minus minus, and this is a minus, right? So they cancel out with the same coefficient. So what we get is minus 1 over 9 ln secant 3x, sorry, let me write it down, meter, minus 1/9, and actually this is a cosine 3x in front of it, so let's write that already, cosine 3x, so yp is that, times ln of secant 3x plus tangent 3x. That's it. Okay, let's see, this is now what is, that's how they wrote it too, minus cosine 3x ln secant 3x plus, okay, that's it. And then the general solution, y is this guy, minus cosine 3x over 9 times ln, yeah, I don't need to write these extra parentheses, right, ln secant 3x plus tangent 3x, plus, and then the general homogeneous solution was by this a cosine x plus cosine 3x plus b, so a cosine 3x plus b sine 3x. Okay.